Panther DMS Player Programming Part 3, Reading from and Writing to the SD card. In this video, I'll show you how to read a file character by character from the SD card and write those characters to a new file, making a copy of the original file. We'll use the Arduino IDE for this. Let us begin. Okay, if you don't have the Arduino IDE up and running, go ahead and launch it and open up the Panther Triggers LED, the last one we did in our two tutorials. We're going to go ahead and edit this file. So before we edit it, first thing I want to do is save it as something else so we don't replace the file we already have. So let's choose File, Save As, and we'll call this one Panther Read Write SD Card. And we'll hit save. Alright, so now we can make our changes and not worry about anything we did mess up our other one. Alright, so we don't need our triggers, so we'll go ahead and get rid of those. And that means we can get rid of our pin modes for our triggers as well. We don't need our read trigger function, so let's get rid of that. And let's take loop and just make it towards nothing right now. And then let's create a function called flash status. So make void flash status, and we'll pass it in an integer to this function, and we'll call it flashes. Okay, so what we're going to do in here is we're going to create a loop. So we're going to make it a for loop, so it does this loop a certain number of times. So let's say for, create a variable as type integer, and we'll call it our variable I. And we'll initialize it to 0. And we'll say while I is less than flashes, and we'll need to increment our I variable on each loop. Okay, and what we're going to want to do inside of here is we're going to want to do a digital write of our status pin to high. We're going to delay 1/4 of a second. Then we're going to set our status pin to low and delay another 1/4 of a second. So all I did was just copy and paste the previous section here, so I can just copy and paste instead of typing it over again. So after it flashes the certain number of times, we want everything to delay for a certain amount of time. Let's have everything delay for 1 second, which is 1,000. So it'll flash a certain number of times and delay 1 second. So we'll be able to read our status and know exactly what our delay is or our message is trying to tell us. Okay. So to read and write to the SD card, we need to include a header file so that it will load up the appropriate SD card files. So let's do an include here. And then the header file we want to include is called sd.h. Okay. And we're actually going to be using a new trigger pin because the not trigger pin, a chip select pin for the SD card, because the SD card needs to know what chip it should or what pin it should use to communicate with, what pin the Arduino chip should use or what pin the Panther chip should use, and what chip it's going to be pointed to on the SD card. So let's do a define here, and we'll call it CS for our chip select pin, and we'll set it to equal 10 just by calling it like that. Now we need to read and write to a file, we need a variable of type file. So let's create that variable type of file, and we're going to be reading one file and writing to another file. So we actually need two file variables. So we'll create one as in file and one is out file. And then we also need another variable of type SD2 card, and we'll just call that variable card. Alright, so one thing I generally like to do is after I initialize my pins is to, especially when I have LEDs, is to make sure both those LEDs are off. So what I'm going to do is I'm just going to copy this piece of code right here, the digital write, and we'll paste it right after our pin modes where we initialize our pins to output. So we're going to have our status pin set to low and our stop pin set to low. So this way it'll force our LEDs to be turned off. Okay, so now we also have this other additional pin up here that we're going to be using called the CS pin. So we need to initialize that as well as an output pin. So let's go pin mode and just type in CS, comma, output. So it makes that an output pin. And we're not going to initialize any LEDs with that, so we don't have to do a digital write to that guy. Alright. So to read and write to the SD card, we have to actually initialize the SD card and tell it to begin. We'll have to tell it what speed we want to communicate as, and then tell it to actually begin after it initializes it. So let's create I like to break everything up in separate functions, basically. So let's create a function called initialize SD card. Initialize SD card. And we're not going to be passing any variables to it. So we'll just have an open close parentheses. Okay, so down here, let's create that function. Just copy it right there to my clipboard. Type in the word void, because we're not going to return anything back. And then call in our function, same name, and then create our function. Okay, so now in here, what we need to do is we need to tell the card to initialize at a certain speed. So we're going to do a while statement, and we're going to say while the SD card is not at the initialization. So we're going to say while not sign, which is just an exclamation mark, card, the variable initialized up above, dot init. And it expects some parameters, this init function. So we have an SPI underscore full underscore speed. That tells us what speed to initialize the SD card. I'm aware of two that there is. There's the SPI full speed and the SPI half speed. But we're going to go ahead and initialize it to full speed. And then we'll pass it in what pin we're using, which is our chip select pin, which is set to 10. And we just set that by setting up the CS variable. So now we want in here, we want to execute some logic. So if it's not able to initialize our SD card, what do we want to do? Well, let's flash our status a certain number of times. So we'll call our flash status, and we'll pass it in a variable. In this case, we'll pass it in 1. So we'll know that, hey, a 1 means this, a 2 means it's something else, a 3 means something else. Okay? Alright. So we initialize our SD card. So now we want to perform the same function and have our SD card begin. So let's do while. And this time we're not going to use the not. We're going to say SD.begin and pass it in the pin also, which is just the CS. And we're going to perform some function, some logic in here as well. And that logic, once again, will be just flashing the status. Okay, so what I want to do now, basically while we have our function here, is just hit this verify to see if I have any coding errors. Okay, so it tells me right there I have a coding error. So okay, right here I see over here I need to have another parentheses to close out my while statement. See, because I have 1, 2 parentheses there, but only had 1 here. So let's re-verify it. Okay, so it looks like everything's compiled okay, and it just tells me how many down here, how many bytes so far I'm using of the 32K that I have for program space. Alright, so we have our initialized SD card function created. So now that we have our function created, we're going to be reading one file and writing to another file. So what I generally like to do is I like to make sure, well, is that file that I'm going to read from there? So let's verify that file is there. So we're going to say if SD.exist. In other words, it's going to say, does this parameter, or just this parameter I'm going to pass into it, exist? So it's going to look for, let's call it Panther.txt. Okay, so it's going to say, does this file exist? And if that exists, it's going to return true. So let's say equals true here. And if it does exist, we will perform some logic to perform something. And if it doesn't exist, we'll do an else. We'll do something else. And the something else we want to do is, let's do a digital write. And this time we'll write to our stop pin. And we'll turn it high so that our red LED will come on. Alright. And now let's also flash our status so that we know, oh, there's something going on. This flashing a certain number of times means something to us. So let's do a while statement. And I'm going to make this a forever and never ending loop. So we'll say while true. So it's going to stay in here forever. I could put the brackets, or because I'm only going to do one thing, I don't have to put the brackets around this while statement. And I'm going to say flash status, and I'm going to say 3. It says so that if the file doesn't exist, it'll flash 3 times. So now we have, if it's one flash, then we know the SD card's not ready. There's something wrong with that. If we get 3 flashes over and over and over again, then we know that the Panther.txt file does not exist. Okay, so now let's perform our logic if the file exists. So we want to say here, so what we want to do is we want to try to open that file up. So we're going to do an in file, which is our input file variable, equals sd.open, and we're going to pass in the name of our file we're trying to open up. It's the same as this Panther.txt file, so let's copy and paste it here. And now we have to tell it what mode to open the file up, whether it's going to be for a read mode or a write mode. So let's do a file underscore read. Okay, so that will open up our file and make it available for reading. Okay, so just because that file is open and available for reading doesn't necessarily mean there's any data in that file to read. So when I first open that file up, if there's no data, hey, I want to perform some type of logic to let the user know, hey, well, I found the file, but there's no data in it. So it's almost like doing a validation on the file itself. So let's say if the in file dot available, open and close parentheses, then close out our if statement, we're going to perform some logic. So in other words, if there's any data available, it's going to go into this function, the if part of it. If there's no data available, it's going to drop down to the else section. And if there's no data available for it, what we want to do is we'll just copy this code right here and paste it in the else up here. So if there is no data available, we're going to once again say digital write our stop pin to high. We're going to go into a never-ending loop, and we're going to flash our status LED twice. So we now have a 1, a 2, and a 3 meanings for our status when those go to status mode. I turn the red LED on, so this way we know that, hey, that's in stop mode. Whereas if you're down here in the logic for our initialized card, you can say I'm not turning the stop pin on to high, because you can push the SD card in and then we want it to continue on. But once you get to this part, it's actually going to say, oh, okay, well, there's no data there, or the file is not found. I cannot continue. So we'll make the stop pin high on here. Okay, so if there is data, what do we want to do? Okay, if there is data, let's do a digital write. And we're going to do a digital write this time to our status pin and make it high so we know, hey, things are good. All right, that's basically what we're going to say when we see the status pin on by itself. Okay, so after we've set our status pin to high, Now we need to open up our output file. We have our input file open, so now let's open up our output file. So let's say out file. Let's just copy this code up here and paste it down here. So let's say out file equals SD open, and this time let's call it copy. Copy.text. And this time we're going to open it up for writing, so it's file write. Now that, okay, so we now have our file open for writing. Now the issue is, if the file already exists, this copy.text file, the file underscore write mode opens that file up for appending. So if we actually want to replace that file, we have to remove the copy.text file. So let's go ahead and do that. We're going to do an sd.remove. Put that a period right there. sd.remove copy.text. So that will remove the file before it tries to open it up. Okay, so we're good with that. Now what we're going to do is, for every character that's in the file, we're going to read it and write it out to a new file. So we're going to say while here, and we're going to say in file dot available. So while there's data available for me to read in, we're going to perform some logic. Okay, so what are we going to perform? Okay, well, we need a variable to store each character that we're going to read in. So let's create a variable of type byte. If I spell it right, and I'll give it a variable name of A. Now let's assign this A a value. So we're going to say A equals in file dot read. Now the nice thing about this in file and dot read method is that when you read a specific character in the file, it keeps track of where it was, so that every time you loop through this process, it's going to just keep going through that file till it reaches the end. So now what we're going to do with that A character, so now we're going to write it out. So just do an out file dot print. We're going to print A out to that file. Now A is a type byte. If we leave it just like this, it's going to write out A as the 2-character hexadecimal value, and we don't want that. We want the actual character that read in to be the actual character we write out. So we're going to prefix this A with a casting statement. Basically all we do is say open parentheses char and close parentheses. So that tells it so that whenever you cast this character to write it out, treat it as a character, not as a byte. Alright, so that's all we have to do in here to actually go through this process and create this new file. So once we've read through the file, we wrote everything out, now we're through reading, we're through writing, we need to close those files. So let's do an out file dot close and an in file dot close to close up those files. Alright, so now we're through with our setup method. Now we could turn on our LEDs here at the bottom of the setup method, or we could turn them on in our loop. Just that the loop will just keep issuing the high even though it's already done. So let's just go ahead and put them in here. So let's do digital write. So let's just copy that code. I'm sure it's right up here somewhere. There we go, digital write. And at this time, I'm going to turn everything on high. I'm going to turn my stop pin on and my status pin to high. So that I know, if both of them come on, that means it's finished with this setup method and that it completed successfully. Basically, it didn't get stuck in here where it says, oh, I don't have the trigger file, or it didn't get stuck in here where it says, oh, the trigger file, or not trigger file, the panther.txt file, the panther.txt file is empty. So basically saying the panther.txt file does not exist, and over here it would say get stuck in here if the panther.txt file was empty. So that's all we really need to have for our program. So now let's just verify it by clicking this button over here, and it compiled successfully. Okay, I'm going to pause this video right here for a second and plug my Panther in. Let's pause this real quick. Okay, I have my Panther plugged in, but before I go to that aspect, let's bring up my Windows Explorer and we'll show you the contents of my SD card. So here, as you can see, I don't have the copy.txt file, and here is the an xpanther.txt file. So the actual panther.txt file is missing. Once again, I said before that the file is case sensitive, but this one has an X on it, so it is missing on this SD card. Okay, so what I'm going to do is I'm going to close this right here. All right, so I'm taking that SD card, I'm plugging it into my Panther. Okay, let me turn my other video on. All right, so what I'm going to do now, all right. Okay, so about ready to upload. So what we're going to do now is just click on the upload button. We're going to go over here, click on the upload using programmer. So we'll click on that. So it's actually starting to upload the program. To the Panther, and now it's done uploading. So as you can see, it's flashing. What do we got? 3 flashes. 1, 2, 3. So that tells me that the panther.txt file is not there. So let's go ahead and unplug the SD card. Let's just do a simple reset on here. Plug it back in. So as you can see, now it's just flashing the SD card one time to indicate, hey, I can't initialize the SD card. So immediately when I push the SD card in here and press that in, you can see it initializes it immediately. We get the red LED back on and the flashing 3 status LEDs indicating that file does not exist. Okay, so let's go ahead and take that file, the SD card, plug it back into my desktop here. We'll open up Windows Explorer, go to that drive again. Now, I'm not going to demonstrate the panther.txt file being 0 bytes. That's just something you can play with yourself if you want to do that. But let's go ahead and rename this, back to panther.txt. Alright, close that out. Now let's take the SD card, plug it back into the Panther. And all we have to do now is just basically reset the Panther just by pulling the power out, plugging it back in, and we now get 2 solid LEDs indicating that our copy mode was successful. So let's take the SD card out of there. We'll stick it back into the desktop. Open back up Windows Explorer. Go to that hard drive. So now you can see here's your copy.txt file, and it's 1K, and so is the triggers.txt file. So now let's open up the triggers.txt file. I'm sorry, not the triggers.txt file. The panther.txt file. Here we go. This guy right here. Let's open that guy up. And as you can see, contains hello and welcome to the wonderful world of hardware programming. Excuse me, welcome to the world of hardware programming. So let's go open up the copy. And that says hello and welcome to the world of hardware programming. So as you can see, we're able to demonstrate in this video how to read from the Panther, how to write back to the SD card as well. So if you like this video, want to see more videos, please like it on YouTube, and I will create additional videos. Thank you and have a great day.